All right, let's take a look at the two quizzes. And I just looked at the test, and the test is pretty much like the two quizzes.
You should show us the test.
Oh, you want to see the test?
Yeah.
There it is.
I can't see.
Huh? It's actually 2 pages.
Oh, that's cute.
Just because the drawings are so big, it just took 2 pages. So it's still 20 questions, all right? So it's not changed how many questions are on the test. But I just got so many of these pictures to draw, I just couldn't fit them all on one page. So, all right, here we go. Let's go through this. And I'll try to go through pretty quickly because you've already done this. Let me change my writing thing here so we can write on top of here. And let me change this to that. All right, we should be good. All right, find the indicated measure. Here we go. All right, so angle A. Where's angle A? That's that right there. So pretty easy. What do we do first? What do all 3 of these angles add up to be? 180. So how do I find the missing angle if I know 2 of them? Okay. Yeah, you could. Either way is the correct answer, right? You could just subtract both of these from 180, or you can add them up and subtract it from 180. However you want to do it. What's 65 and 65? 130. So 180 minus 130 would be 50. So that would be 50 degrees. Pretty easy, right? Yeah. All right. So that would be 50 degrees. Angle ACD, where's that? ACD. That would be this big one right here. That obtuse angle. All right. One little thing to do here. What would you do here? Yeah, that's what I would probably do. I would probably go, there is, 180 minus 65, and that's what, 1 to the 15? Okay? So you could do that, or, remember, this is a exterior angle. You could just add these 2 together, okay? Whatever you think is easier, all right? So 65 and 50 is also what? 115, okay? So you could do that either way. Everybody got it? All right, so that'd be 115 degrees. If it's an angle, make sure you put the little degree symbol there. No questions there, right? All right, let's keep going. Same kind of thing, except you have some X's in here. All right, same idea though. And the thing we just talked about, that exterior angle, that's going to come into play here. So angle L, where's angle L? Right there. All right, so that's what we want to find. Obviously, we don't know what X is, so what do you think we're going to have to do? We don't know what X is, so what do you think we're going to have to do? Solve for X. Very good. Okay, so how do we solve for X? Well, I got 2 angles inside the triangle. I got an angle outside the triangle. That's an exterior angle, correct? Well, what are these 2?
Oh,
remote interior angles. That's right. So this X is equal to what?
X minus 60 plus X.
Right, plus the sum of those 2 remote interior angles. So I go X minus 60 plus X minus 20. Everybody see that? That's the key to this problem. That's why I put this problem on here, so that you know that the exterior angle is equal to the sum of the 2 remote interior angles. All right, now it's just math, isn't it? Let's do this. X plus X is 2X. Negative 60 minus 20 is negative 80. You can do this a couple ways. You could subtract a 2X. You know what I'm going to do? I'm going to subtract an X and then do what? Add an 80. Wouldn't you? That way my X stays positive, all right, even though it's on the right side. Look, I put the X on the right-hand side. I took that minus 80, put it on the left-hand side. All right, so that will cancel. So what do I got? I got 80 equals what? 2X minus... No, because I'm adding an 80 to both sides. That's the whole reason why listen to what I said. Okay, I'm explaining it. Then you're asking questions of what I just explained. I subtracted an X so that when I do my subtraction here, I get a positive X. I don't have a negative X. I could have done what? Subtracted a 2x, but then I'd have a negative x, right? So then I would have had a negative x equals negative 80, and then I got to do another step. What's the other step? Divide by a negative 1, or multiply both sides by negative 1, and I would still get x equals 80, all right? You figure that out. I'm not here to teach you the algebra, but that's what it would be. But is that angle L, though? Is that my answer? No. Angle L is what? It's x minus 60, so it's what? 80 minus 60, which would be 20 degrees. So angle L is 20 degrees. Everybody got that? All right. But the key to this, I mean, that was the easy part, just plugging it back in. The key was understanding that the exterior angle is equal to the sum. What does that mean? Sum. What do we do? Add them up. Okay, add the two remote interior angles. Everybody good? All right. Angle M. Well, that's just as easy, isn't it? It's actually easier. We did all the work. We got x. So what's x minus 20? It's 80 minus 20, which is 60. Good. And so angle M is 60 degrees. Easy as that. Any questions on that? All right, let's keep going. Now, here's this stuff. Some of you guys do really well at this, some not so much. Oh, what happened to my line right there? Why isn't there a line there? There it is. Yeah, it's there, but then, oh my goodness. What did I just do? I guess. I'll just zoom up a little so I can see it. I don't know, it just goes away when I zoom out a little bit. All right, so there we go. That's good enough. So it says write a valid congruent statement. Now, I don't mark it wrong if you do this, but some people are putting the congruent statement second and the reason, the theorem, first. But what does it say? It says write a valid congruent statement. They say that first, so I would put it here. I definitely wouldn't mark it wrong if you put it in the wrong blank, but I don't know. To me, it just makes sense that you would put the statement first. Wouldn't you? Yes. Yeah, but again, it does not matter. All right, what are you going to call this triangle right here? Well, not angle. A triangle. Right, and I had people putting an angle right here. Anybody would admit to that? It's a triangle, okay? It's not an angle. Some people put angle. Some teachers would mark that wrong, but I let you do it. Okay, ABC. So how do I write this one? Usually we write DEF, right? ABC, DEF. But do we do that on this one? No. Which one matches up with the A? How do you know it's the F? I'll show you why. Come on, listen. Okay, I don't know what's going on, but I need everybody paying attention. I don't think I got everybody's full attention. So how do I know that angle A and angle F match up with each other? I'll show you an easy way to do it. Look to see what's opposite angle A. The one with two tick marks, right? Everybody see that? Everybody looking up here? I don't see everybody looking up here. So look, what's opposite angle A? Two tick marks. What is opposite the two tick marks in the other one? Angle F. So guess what? They're going to be equal to each other. Do you see that? So it's going to be what? F. Oops. I just yelled at you. I didn't yell, but I just told you make sure you put triangle. So F. Which one is with the B? Well, B's got this one little arc here. Which one has the one arc over here? Well, they both do. I should have put two here, but you get the idea. The original one arc. So it's E. Everybody got that? And then, of course, what's left over? The D. So you got to make sure you put them in the right order. Some of you guys got it wrong because you did not put it in the right order. You have to. Okay, I told you from the beginning that A and the corresponding parts have to match up.
Jaden, Oni to the office. Jaden, Oni to the office. Thank you.
All right, now, what's the reason? Now, not the red ones, okay? Forget the red ones. Just the stuff that they gave us. Go ahead, Gianna. Side, angle, side. Very good. See, I got side, got an angle, got a side. Got this side, this angle, this side, so it's side, angle, side. And that's all you have to write for that. Make sense? Yeah. All right. Let's keep going. Tell you what, before we even put the the congruent statement together. Let's just see, why are these triangles congruent to each other? Well, I got an angle. I got another angle. Is there anything else I can tell from that picture? The side. Right, that one right there. Okay, and just put one tick mark there. Everybody see that? So this side on this triangle is equal to that side on this triangle because it's the same side, right? Okay, it's called the reflexive property. If we were going to do proofs, reflexive property is something that you would probably know right away, but we're not really doing proofs. So what's my reason then? Angle what? Angle, side, angle. So if you wanted to do that right away, you can. It's up to you. Now, what are my congruent statements? So let's do this top one right here. Let's go WXY. Do I have to go WXY? No, I could have gone WYX. I could have gone YXW. Could have gone YWX. All right, I could have done a bunch of things. I just chose that one, but whatever I choose for the first triangle, the other one, the corresponding parts got to match up. Agreed? So which one goes with the W over here? Yeah, because this one's got that one little arc. This Y's got one little arc, so we're going to put Y first. What about the X? Well, the X is the one without any arcs, correct? So which one matches up with the one without any arcs? The Z. And then you only got one thing left over. What do we got? So what matches up with the Y? This Y right here is a double angle. This one, so what's there? It's a W. It's my only other letter I could use. And there you go. That's how you do that. Pretty easy, right? Yeah. And of course, the quiz I just gave back to you, and we're going to do that in a few minutes here. It's the same thing, except we're using right triangles, correct? And some of you struggled a little bit with that. Let's take a look at this. Is there anything on here that I could mark that I know that they didn't mark? Yeah, that reflexive side, right? That one that's the same on both of them. So without even putting my triangles down, what's my reason for this? Yeah, side, side, side. Okay, now let's call this one. What do you want to call this one? QRT? So triangle QRT is congruent to triangle. Which one matches up with the Q over here? Well, the Q does. Yeah, that's a pretty easy one, right? Then the R, it's got no arcs, right? Or it's the one across from the middle one, the 3 tick marks. So is S. And then obviously T. That's an easy one. Everybody good with that? Questions? Again, you didn't have to call this QRT, did you? You could have called it RQT, or you could have called it TQR or TRQ. Doesn't matter. As long as the Q's match up, the R and the S matches up, and the T's match up. All right? And I do. I go through there. You may have written it different than I wrote it in my answer key, but then I have to look at it and see what order you put this in and make sure it's in the correct order. All right? So that's what I do. I go through there and I look at that. All right? Let's do this one. All right, so let's mark some stuff. It says find angle A. So this is what we're trying to find at first anyway. If BCE is 132. Now look, all three of these problems, if BCE is 132 here, how do they say BCE is 125 here? Two different problems, that's it, okay? So they don't rely on each other. Everybody got that? So whatever I get for this, if I get something for angle A on this problem, does not mean it's angle A on this problem and this one, all right? They're three separate problems. We got it? All right, BCE is 132. Where's BCE? BCE. That's this big angle. That's not just any old angle. What is it? It's an what? An exterior angle, right? So how in the world do I find that? Well, look what they tell you right off the bat. They tell you that this side and this side are equal to each other. So what did we learn about a triangle that has two equal sides? What's true about the opposite angles? The what? No. Listen to what I'm saying. Listen. Shh. Come on. I got these two sides equal to each other. Forget all this. Forget this BD line. Forget this extended line. Just look at this triangle. It's an isosceles triangle, correct? When we have an isosceles triangle, two of the sides are equal. That means that the opposite angles are equal as well. So if I mark this one with one arc, what can I do here? Mark that with one arc because they're equal to each other. Everybody see that? That's really important to understand. All right. So this is what we got. So this angle and this angle are the same. So really, what am I going to do? Am I really solving directly for angle A? No, I'm going to solve for this angle right here. Okay. And then I know that this one and this one are the same. So I'll just, whatever this one is, that's what this is going to be. You got it? And how do I find this? We've done that once already. You got it. 180 minus 132. And that's 48, correct. All right, so if this angle is 48 degrees, talk to me. This one is 48 degrees, okay? And so that would be 48 degrees. Everybody good with that? All right, let me erase all that stuff. Oops. Let's do that. Let's click on that. Let's click on that. Now I can delete it all. Very good. All right, let's do the next one. Now they tell you something different. They tell you something else. That BD didn't really come into that problem with number 8, did it? But now it's going to. So it says find an angle ABD. Where's that? ABD. That's this little one right up top here. Trying to find that angle. That's going to be what we're trying to find. And what do they tell you? They tell you that BD is perpendicular to AC. BD, AC, perpendicular. So what can I put here? A right angle. That's right. It's perpendicular, forms a right angle. Both of these are right angles. Everybody with me on that so far? Yes? All right, they tell you one more thing, don't they? Angle BCE, where is that? BCE. Oh, it's that exterior angle like we had on the other problem, but this is 125 degrees. Now tell me something about these two triangles right here. Triangles aren't equal. What do we say about triangles? They're congruent to each other. We always say congruent. BCE. No. ABD. Nope, it's just this little one. There's A, there's B, it goes down to D. All right, so it's not ABC, it's ABD. So it's this little skinny one right here, okay? But you're right, we could find that one at the top, might help us out a little bit, okay? But we don't really have to find that whole thing, all right? There's another way to do it. Since this is a right angle, that should help us out a little bit. So what do I know about both these triangles? They're both right triangles, okay? So let's do what we were going to do before. You do remember, though, right, that this angle and this angle are exactly the same? All right, so let's find this angle. How do I find this angle right here? We did it once already. 180 minus 125. What's that, 55? All right, so that's 55. What's this angle right there? It's also 55. How does that help us find this? Okay, so 55 plus 90 plus this equals 180. Now, since this is a 90, what's true about the two acute angles of a right triangle? Look, if this is 90, we're always going to take that away from 180, aren't we? So what do these two add up to be? 90. Okay, when you have a right triangle, everybody hear me? When you have a right triangle, the other two angles, the acute angles of the right triangle must add up to be what? 90 degrees. That would be the quickest, most efficient way to do that. Okay, you don't have to do the 180 because you're always going to go 180 minus what? 90. And what is that? It's 90. Make sense? All right, so how do I find this missing angle? Now we're finally ready to get our answer for this. How do we find it? One quick little thing. Do what? Yes, 90 minus 55. Very good. So 90 minus 55, and that's what, 35? All right, so that's this angle right here, and that's our answer to this, 35 degrees. Everybody good? Ask me a question if you have one. Don't just sit back thinking, I have no idea what he's doing. Okay, if you don't ask, I don't know. I don't know what you're thinking. Oops. Let's get rid of that. Oops. Oh, I got to click on this. There we go. Now I can get rid of that stuff. Good. All right, let's do one more of these, and then we'll do the quiz. And we probably don't have to spend too much time on that because you just took it, and I told you what's right or wrong. So we'll go over a few of those, though. All right, so find DC. This time we're not finding an angle. We're finding a what? A line segment, correct? I'll put 2 tick marks here. Why did I put 2 here? Because these already have what? They already got 1. All right, so I'll make another one with 2. Everybody understand that? All right. Now remember, what's true about these 2? Well, actually, let's read the rest of it. I'm sorry. Let's read the rest of it. It says, find DC. That's what we're trying to find right there. That's what we're trying to locate. It says, if BD bisects AC. AC is right there. Okay, BD is this one right here. Now, it doesn't say it's perpendicular this time, does it? All right, but it does say it bisects AC. What does that mean if it bisects it? Cuts it in half, right? So if DC is got 2 tick marks, what's AD have? 2 tick marks. Now, if that's all they told you, would you be able to solve for DC? No, you wouldn't. You don't know any numbers. They didn't give you any numbers at all.
There's a number right there.
I said if that's all they told you. Okay, but that's not all they told you, is it? Okay, they do tell you that AC equals 24. So watch. This whole thing from there to there is what? 24. So very simple now. Once you realize it, just cut it in half. You're right. And what is DC? It's just 12. If I wanted to show my work, what would you do? 24 divided by 2. All right? And so DC is 12. Just like that. What do you think? All right. Is this coming back to you? Yeah, because really, we've been using a lot of these principles even later on, haven't we? Yeah. All right. So here we go. This is the one I just gave back to you. Let's go through these kind of quick here. And then we got some problems to do down the bottom. Got a little slope action. Got a little distance formula stuff. Got this mid-segment stuff we're going to do. Yes. Question? Never mind? Okay. All right, let's take a look. Congruent statement and name the theorem. So however you want to do it. I don't know. I kind of like naming the theorem first. Do you? Doesn't matter. It really doesn't. So let's take a look at this. What do I know that they didn't give us? Just by looking at this picture, what can I say about these 2 triangles that they didn't tell us? What side? BD. Right. BD equals BD. Would you agree with that? So look what they give you. They give you, and I actually give you the theorems up here, so that's kind of nice, right? I give you an angle and a what? Yeah, but you don't have sides up here. What do you have? You either got angle, you got a hypotenuse, you got a leg. What is BD? It's a leg. It's not a hypotenuse. A couple of you put hypotenuse on this, right? What's the hypotenuse of this left triangle? AB or BA. That's the hypotenuse. How do I know it's the hypotenuse? Because it's opposite the what? The right angle, right? What is BD? It's a what? It's a leg, all right? So it's a leg. So I've got an angle and a leg, but do I have AL? Is that what I use? No, I use leg angle. So that's my reasoning. That's the theorem, my congruence theorem, leg angle. Everybody see that? All right, and now we do the triangle congruence. That shouldn't be that big of a deal. We've talked about that already today. So angle ABD is congruent to angle. I said angle. Shame on me. What should I say? Triangle ABD. All right, now watch. If I go ABD, what am I going to go over here? CBD.
I got that right. You should have given me half a point.
I did give you half a point.
No, like
Half of a 1?
I
No.
don't know.
I don't give half points. My first year I did that. I was given like half points and quarter points, and it was a pain. I've never done it since then. Okay, so 1 point is the least I'll give you. All right, what about this one? What do you know that they didn't really tell you, but you could look at it and say? What is it? PS? What about PS? Same as what? No. Nope. They do tell you that this and this, but that they told you that PR and SR are equal to each other. They told it to you. But what's something they didn't really tell you, but you can look at it and say, oh yeah, they're equal to each other. The legs? Why? Why is this leg and this leg equal? Give me a reason. There's no reason. I don't know. Well, they gave that to me. They gave me that they're right triangles. What can you figure out? What about R? Just point R? Well, it's not. You can't just say angle R. There's 4 angles that come out of there. Right? QRP. Do you see that? Well, I'll just draw it. Is this one you're talking about? And this one. These two are equal to each other. They're always equal to each other. Why? Because they are what kind of angles? No, they're not reflexive. Vertical. Very good. Vertical angles. They're vertical angles, and vertical angles are always equal. Anytime you got 2 lines that intersect each other, you have 2 pairs of vertical angles. You got this pair, and you got this pair. But does this second pair right there really do anything for us? No, it doesn't. So these are equal, right? Just by looking at the picture, I know for 100% fact that they're equal to each other. So now, let's think of the congruence theorem. Let's go through these right here. I've got an angle, and I got what? What is this? What is it? It's a hypotenuse. How do you know it's a hypotenuse? It's not left. It's opposite. Opposite. That's the word I used earlier. Okay, it's opposite the right angle. So I've got a hypotenuse and I have a what? An angle. Do I have that up here in my list? Yep, I got it right there. Hypotenuse angle. So that's my reason. Do you see this? A lot of people miss this. I was really surprised. I thought you guys had this down pat. But you got a hypotenuse, and I think some of you don't really know the difference between a hypotenuse and a leg, right? Remember, the hypotenuse is always what? Opposite the right angle. Everybody see that? So that's your hypotenuse on this triangle. The other 2 sides are just legs, all right? So this is a hypotenuse, that's an angle, and that's our reason. All right, let's do this pretty quick. What do you want to call this? PQR? PQR is congruent to triangle. Now watch. Which one matches up with angle P up here? Angle S. I'm going from the no arc angle, right, to the right angle to the vertical angle. Everybody see that? So what am I doing here? I'm going from the no arc angle to the right angle to the vertical angle. So what's it going to be? STR. All right, I sure hope some of you guys that are just not really paying full attention, knowing what you're doing, but you might be stopping somebody else that doesn't know what they're doing. Here we go. Let's do one more. Again, what in here, we've done this once already, what in here do we know without them telling us? Okay, the hypotenuse. So we'll put a double tick mark there since that's got 1 and that's got 1. Everybody see that? So they are right triangles. So I can use one of these. What do I have? Do I know anything about this angle and this angle? Nope. Anything about this one and this one? No. I do know, though, that I have a what? I got a leg and I got a what? Hypotenuse. Do I have that up here anywhere? Yep, right there. But we call it hypotenuse leg, so that's my reason. Hypotenuse leg. Let's put the triangles. Let's do the top one. Let's go XWZ. XWZ. It's congruent to. Now watch, if I go XWZ, what am I going to go down here? XYZ. Do you absolutely have to go XWZ to begin with? No, you don't. All right, but these two have to match up. The X and the X have to go together, the W and the Y, and the Z and the Z. All right, so make sure that you have it like that. All right, enough of that. Let's do these. First 2 were pretty easy, weren't they? If this is 16, what do I call this CD? Don't give me the number answer. It's a what? A mid-segment, right. And what do I know about the mid-segment and the opposite side? They're equal? The mid-segment is half of that opposite side. So if that's 16, now some of you didn't show your work, but I was okay with that because it's such a simple little thing to do. But if I wanted to show my work, what would I do? 16 divided by 2. Okay? And that's how you get that. What about this? They kind of give it the opposite way, don't they? All right, this time they give you the mid-segment, but they're asking for DF, which is the opposite side. So if this is 9, what's my math? 9 what? Times what? 2 is 18, and so that would be 18. Those are really easy. Agreed? This one is a little bit more difficult, but it's the same idea. Everybody look. Shh. Swanka, please. Let's take a look. You can look at it two ways. You could say that this side is twice this one, correct? Or you could say that the mid-segment, x plus 2, is what? Half of this one. Would you rather use the times 2 or the half? Yeah, absolutely times 2. All right, so I'm going to go 3x minus 8. That's the longer one, correct? That's equal to what? Twice what? X plus 2. All right? They don't equal each other. Okay? They do not equal each other. Look, that's a lot shorter than this one. In fact, it's how much shorter? It's half the length of this one, okay? But I think this is a little bit easier. It'll still work out either way you do it. All right, so let's do the math real quick. 3x minus 8 equals 2x plus 4. Subtract 2x from both sides, you get an x. Add an 8 to both sides, you get a 12. Is that my answer, though? No, it asks for SQ, which is this one. So what do I do? If you wanted to, if you didn't want to go 3 times 12 and then subtract an 8 from it, you could do what? What would be a little bit easier? Just go x plus 2, which would be what? 14, and then do what to it to get this? Then double it, right? So I think that might be a little easier, don't you? Than just plugging it into this. Either way, you should still get the same answer. And what'd you get? 28, all right? Because this would be 14, correct? And this is double this, so that would be 28. All right, so this is the key. If you missed that problem, it's probably because you didn't set it up right. Would you agree with me? Okay. Do you understand how to set it up now? All right, because you might see something like that on the test. You just might. All right, let's do this. Find the slope. Let's write it down. What is the slope? How do I find the slope? Y what? It really doesn't matter if you go 2 or 1. Y2 minus Y1, and then x2 minus x1. Now, guess what? Right, that's exactly what I was going to ask. Guess what a few people did? They put the x on the top and the y on the bottom, all right? It's the y's on the top. How can you remember that the y goes on the top? It's rise over run, and the y-axis is your rise. The x-axis is your run. So always put the y on the top. So let's do both of these, DE, right here. So let's subtract the y's. And it really does not matter. I don't know why there's so much yapping today. Svenka, you're a big part of the problem. You're usually attentive, not today. So let's pay attention, because other people need to. So let's take a look. Let's subtract the y's. It doesn't matter what order you subtract them in. All right? You could go -2 minus 1 or 1 minus -2. But if you go one way, you got to go the same way with the x's. All right? Just remember that. We said y2 minus y1, so let's say this is our second point. So what are we going to do? -2 minus what? 1, and then do the x's. 0 minus, is it 0 minus 4? Nope, it's 0 minus what? -4. And so what do you get? -3. What's minus negative? It's +4. That's your slope right there. Now, you probably, actually, they didn't tell you that that was the midpoint, so you can't really say that, oh, I know that's the mid-segment, so this and this are parallel to each other. You can't say that because it doesn't tell you that this is the mid-segment. Would you agree? So you are going to have to do the work to solve for BC. So let's do BC. And they should, if you look at them, you probably are thinking what? You're probably thinking that probably is the mid-segment. So these should be parallel. So this slope right here should be what? -3/4, okay? But let's do the work. All right, BC, it's right here. So it's -2 minus 4, -2 minus 4, and then it's 4 minus -4, 4 minus -4, and that's negative 6 over 8. What happens to these? 2 goes into both of those, 3 times, 4 times, and there it is. Okay, so this is the mid-segment, isn't it? Because it's parallel to that side right there. All right, let's do the length. Do you remember the length? It's the same as the distance. Agreed? All right, and then this is what? X1 minus X2. You go 2 minus 1. It doesn't make any difference. Oh, this is not a X. What is it? It's a Y1 minus Y2. Again, it doesn't matter what order you subtract them in. So let's do DE. It's the same two things, but now we're finding the lengths. Okay, so we showed already that they are parallel to each other. Let's show that this is half of this, and it should be if we do it right. So let's do our little formula. We could do a little bit in our head. We don't have to write down every little single step, do we? So let's do the first step, though. So let's do the x's. Negative 4 minus 0. Let's do the y's. 1 minus negative 2. Everybody with me? Okay, negative 4 minus 0 is negative 4. Negative 4 squared is positive 16. Okay, why did I put a minus there? It should be a plus. All right, what about this? This is going to be what? A 3. So 3 squared is 9. Now look, a couple people, maybe one person, I don't know. 16 plus 9 is what? 25. Okay. What is the square root of 25? It's just the number 5. Didn't I make a big deal about that yesterday, I think? It's not the square root of 5. It's just the number 5. I still had somebody putting that. That is not the same thing. It's not, okay? So what do you think this one's going to be without really doing much math at all? What do you think? It should be 10. Let's just see if it is. All right, so we do this. We do this. BC. So we subtract the x's, negative 4 minus 4. Subtract the y's, 4 minus negative 2. This is going to be negative 8. Negative 8 squared is positive 64. This is going to be 4 plus 2, which is 6. Squared, forgot the squared, is 36. Keep it under a square root. I've had people forget the square root. Okay, they write it the first time, but then they don't include it because they're just too lazy. What is this? The square root of 100. And what is the square root of 100? It is 10. All right, so it is. This is a mid-segment, isn't it? Do you agree? That's 5. That's 10. Same slopes. They're parallel. So this DE has got to be the mid-segment. All right. Well, those are the two quizzes. You do have a problem on here that we have done as a homework problem and we've gone over in class that I put on the test that is not on one of these quizzes. Okay? But
Please don't tell me that was the one that I really struggled on.
I'll tell you what. I'll draw it for you. Okay? But I'm not going to do it for you. So I will let you look it up.
Are you going to leave the numbers the same?
No, the numbers are different.
Yes. I need to get that emphasis. Daddy, stop growling at me. Not me.
You guys watching? Is this a waste of time? Sounds like it's a waste of time.
That's not. Keep drawing. This is going to be the one problem that we're going to have to look at all of this.
This isn't exactly drawn to scale. Hold on. Let me this one kind of goes,
Can you tell us where it's from?
I don't know, you look it up. You look it up. That's a little bit better. Okay? So here's what they tell you. They tell you that this one and this one are equal and this one and this one. So that means all three of these are equal. They give you an angle. They give you this angle right here. I'll just put an arc there. They give you a number for that. All right? And then they ask you for 3 different angles. They ask for this one. they ask for this one, and they ask for this one. Okay? So they give you this one. That's a number, okay? Whatever it is. Okay, you can make a number up, whatever that is. Okay, they tell you that, and they ask for the other ones. Okay? Look, if these two sides are equal, we talked about this earlier today. If these two are equal, then what? This and this are equal. Agreed?
So then we
Okay.
just 180 minus that what they give us. And
So I'm not going to do it for you. We actually did that in class together. Okay? And I doubt it's on a video because it was probably just going over homework. But you can look at it, you figure it out, find it, okay? Work on it. If it's an even number, you can photomath it, right? And then at least you know what the answer is supposed to be. Where's everybody going? The bell hasn't rung yet. All right, so it's Monday. I hate Monday tests, but that's the way it worked out. So we're taking it on Monday. It's actually the test day. Did you know that? You know how classes are supposed to have test days? Monday is a math test day. But don't tell anybody. But I rarely stick with that. All right. Be ready for it on Monday. Have a good weekend.